for joining another one of our great big data webinars. Today's focus is on how the financial services industry can utilize big data. We're running today's session in partnership with Hortonworks, and I have two distinguished guests from Hortonworks on the call, Chris Hackett and AJ Singh. I will let them introduce themselves a little bit later on this webinar. So a couple of quick housekeeping items. If you have questions, please go ahead and type them into the GoToWebinar window, and we will answer all the questions at the end of the broadcast. All right, so we've packed this webinar with a lot of great content. Probably had too much for the time, but we're going to try to get through this. The webinar is geared towards individuals who have some working knowledge of big data, but desire for practical knowledge of how the organizations are leveraging this type of technology in the real world. We're going to start with some very quick company intros, then talk about how financial services are leveraging big data from a broad brush, and then we're going to dive into a couple of case studies. The first one will be on fraud, and then I'm going to turn it over to AJ, who will cover a number of real-life cases that Hortonworks is actually working on. And then we'll end with some suggestions on how to get started. And along the way, just to keep everybody awake, we're going to have some poll questions, which I always enjoy doing. If you're eating lunch, sit back and enjoy. All right, so we always joke internally that Pactera is one of the largest companies that you may never have heard of. We have about 23,000 employees across the globe with 35 offices. Our services range from advisory services, CRM, digital media, QA testing, localization, and the area that I care most about, which is BI and analytics. We are an end-to-end consulting firm, both onshore and offshore. We're actually on the NASDAQ under the symbol PACT. So my role, my name is Kurt Luke, and my role in the organization is to lead the North America BI and analytics practice. And within our practice, we're investing literally millions of dollars in expanding our big data footprint. The value proposition to our clients is frankly irresistible. It's a great place to run projects, and the payback on the projects, as I'm sure some of you already know, is literally within months. So with that quick background, let me turn it over to Chris Hackett, who works in business development at Hortonworks. And Chris, go ahead and take it away.
All right, thanks, Kurt. So thank you for your time today. As Kurt said, I'm with the sales team here with Hortonworks and reside in Charlotte. But what I'd like to do is just take a few minutes to talk about Hortonworks. And really, before I jump in, I can't talk about Hortonworks without first taking a moment to talk about the history of Hadoop. What we know of Hadoop really started back in 2005 when a small group of engineers from Yahoo started to work on a project that to build a large-scale data storage and processing technology. They did this to store massive amounts and varieties of data to underpin Yahoo's most critical application, which is known as search. The initial focus was on building out the technology. The key components were HDFS and MapReduce. That really became the core of what we know of as Hadoop today. In 2008, the team realized that Hadoop usage had grown throughout Yahoo to the point that many applications were being used in a data management platform. And as a result, the team's focus extended to include a focus on operations. Now that these applications were beginning to propagate around the organization, this team realized that it was necessary to scale out Hadoop. So also at that time, other organizations outside of Yahoo were using Hadoop, companies like Facebook, large companies like that. So again, they went from starting an open source project to now you've got organizations outside of Yahoo using Hadoop, and we've put in development services as well as a set of operational management tools. In 2011, the team that started this technology left Yahoo, with the blessing of Yahoo, to create what's known as Hortonworks today. This was done in order to fuel mainstream adoption of Hadoop, which brings us to where we are today. I mean, our focus is an enterprise approach to Hadoop. Next slide, Kurt. So at Hortonworks, our commitment is really committed to 100% open source. We're working with the Hadoop community so that anytime new technology is added to Hadoop, it has to go through the Apache project committee. We're making sure that we stay 100% open source to avoid vendor lock-in. We're uniquely endorsed by the partner community. The partners that you may be working with, Microsoft, Teradata, SAP, just to name a few. Yahoo, which is not only a partner of ours, but they're an investor as well as a customer. The platform has been certified for the enterprise, and we provide world-class service around the technology. This core set of engineers that broke off to start Hortonworks works for, they're still part of our organization. Next slide. Again, you know, the strategy is to innovate the core, continue to contribute code to the open source community, make sure that it's certified through the rigorous processes of the Apache Software Foundation, and then, you know, one key factor or one key differentiator with Hortonworks is that we want to make sure that we interoperate with your existing ecosystem, meaning, you know, we know that you've made investments in your data systems. You don't want to scrap all that technology. We're going to give you that ecosystem interoperability so that you're able to add. At Hortonworks, we look at ourselves as a +1. Okay, Kurt? And again, this slide talks more about the ecosystem interoperability. Again, you've invested in the systems, you know, your business analytics, your databases. We're here to, you know, we believe that Hadoop is going to become part of the mainstream data architecture inside most organizations. This means as a complement to the databases, data warehouse technologies that you already have in place, we want to make sure that this coexists well with everything you already do, including your existing analytic applications, development tools, any operational processes. And for us, I mean, this philosophy is a huge part of our focus, just making sure that we're ensuring interoperability with your existing systems, tools, and processes. Okay, Kurt. And let's go to the next slide. We just talked about this one. You know, it's when we look at this ecosystem interoperability, we want to make sure that you know, one of the first things that we did was to establish strategic partnerships, and we did this through deep engineering work. Again, just to make sure that we're able to work with the technologies, these key technologies that you already rely on. You know, Microsoft, Teradata, SAP, these are some of the larger vendors in the market space. And again, these organizations, you know, they agree with our approach to Hadoop and the fact that we are true stewards with the 100% open source enterprise Hadoop. Okay? And this slide again talks about, you know, the fact that we're the only 100% open source distributor of enterprise Hadoop. It's been certified, tested at scale through our partnership with Yahoo. We've been able to test this at over 40,000 nodes. And again, we look at the fact that we're able to give you a deep ecosystem interoperability. Okay? And the last thing is that, you know, we want to make sure that you know, we're a leading provider for Hadoop support, and we do this through Hortonworks University, and we offer courses for both development as well as operations. You know, if necessary, we can provide consulting services from ourselves and from our partner Pactera. Also, you know, anyone that's looking to get your hands on Hadoop right now, we have a free download, which if you go to Hortonworks.com, you can go to our sandbox, which is going to give you a free download. It's a quick way to learn Apache Hadoop, and you're able to port this this technology with you. Okay. All right, Kurt.
Thank you, Chris. Let's turn our focus from this point forward really on how big data plays in the financial market. So I get asked this question a lot as we're engaging with customers as they're exploring big data, and this really is not a factor of an industry. It's just a factor of the newness of big data. And the question is, really, why do I need big data? And after stumbling on the answer a number of times, I've really come down to really two reasons. And the first is to reduce cost. And for a lot of customers, it's as simple as that. And the second is to do something you could not do before. For many organizations, a simple reduction or at least maintaining the current spend on storage was the factor that made big data appealing. The more interesting projects, although, and I think this is where people eventually get to, are around doing things that organizations could simply not do based on the size, the variety, or velocity. So things like 360-degree view of the customer, fraud detection, which we're going to cover both in this webinar. These are the things that I would categorize in that second category of what can you not do today. And that is the question that we lead off with many times as we engage with customers when they're trying to figure out, do they need big data? All right, the next slide here talks about the many aspects of smart banking. And yes, I know adding smart in front of something doesn't actually make you smart, but it is a great marketing ploy. Here at Pactera, we are rebranding a lot of our industry solutions with the term smart commerce, smart cities, smart banking, and so on. The idea, all joking aside, is that current solutions and technologies are going to need a refresh. Big data is such a game changer that current technology and business processes have to be reviewed. The items highlighted in yellow are areas that we feel should be carefully reviewed for enhanced capabilities with big data technology in the financial institution. For example, we feel that new data models down near the bottom of the screen will emerge that will incorporate both the old way of storing data as well as new methods that can be explored with this newer technology. All right, let's take a poll question here. So what is the definition of polyglot? All right. So the point of this slide is that big data is not going to solve the world. A polyglot approach is actually needed. And polyglot, if you answered the question right, was basically it's using multiple languages to answer some complex questions. I know even the Hortonworks team on here would agree that big data is part of the solution, and Chris actually made this statement a few times during his portion, but there are many other existing and new technologies that also are part of the solution. I believe over the next few years, the line will be blurred even more than it is today between big data and traditional database technologies. We at Pactera believe that every business problem should be addressed with the right technology. Whenever a new technology springs up, and we see this all the time, if you've been in IT for long enough, that people jump on to that technology to try to use it for everything. But look for technology vendors like Hortonworks that coexist and play well with the existing vendors. And that's why there's strong partnerships with Hortonworks and companies like Microsoft and Teradata. At Pactera, we strive to know the technologies beyond the hype and to take a polyglot approach. Okay, so for some of you all, this may be a new slide. I'm going to spend just a minute kind of talking through what some of these funny terms may be. The basic element is the HDFS, which is the heart of big data. It's basically the storage of the data, and I think the best way to understand it is by thinking of it in the same terms as your laptop. You basically take files and you place them into a folder. You don't care what's in the file. You don't build structures before you put the data in onto your laptop. And the exact same concept emerges with big data. Hence, if you kind of play that forward, there's huge, huge savings by being able to just throw your data onto, in this picture here, this big data lake, without having to go through all the ETL that we normally have to with figuring out the exact right structure before you store it on there. All right, so a couple of terms. Flume, this is the tool that ingests files, so I always think of F and Flume for files. And the next one is Scoop. This is a tool to get data and put data from databases like Oracle, Microsoft. Hive is another tool within here, and this is a tool that basically allows you to interact with big data in a ANSI SQL, or I should really say near ANSI SQL type of format. Pig is a scripting language. Think of it like T-SQL or PL/SQL or even Python that can be extended with Java and other languages. Yarn is a new concept in Hadoop 2.0. I'm going to leave that for another webinar, but just so you know, it makes Hadoop scalable and more flexible. All right, so let's move on to our first use case, and keeping in the holiday theme, we're going to talk about fraud. All right, so let's go ahead and run that poll. So the poll question is around bank robberies. Are bank robberies on a decline, or are they actually increasing? All right. So as this guy on this picture, and I showed this to my kids last night, and they got a big kick out of it. But as this guy would attest to, there's really no such thing as easy money these days, at least not in this method. Based on declining bank robbery statistics, criminals seem to be realizing that it's hard to make a living by following in the footsteps of Bonnie and Clyde. In fact, in 2009, there were fewer than 22 bank robberies in a trio of counties centered around Augusta, Georgia. Last year, there were only 8 bank robberies reported in that same area. According to the FBI, I'm pulling some FBI stats here, bank holdups have dropped nearly every year since 2003, when nearly 7,500 robberies were reported nationwide, with 77 million taken in 2011. The last year that this data came out, there were 5,000 bank robberies with 38 million. So pretty substantial decline. So are people discontinuing trying to steal? Well, we all know the answer to that is no, they're not. But if you guessed that people are taking an easier route, you're right. Electronic and quite sophisticated methods to steal money are definitely on the rise. Frankly, it's easier money, and the sentencing is much shorter. There's many ways that a bank can be defrauded, but let's focus our discussion around credit card and ATM fraud. So this sets us up for a big data discussion around detecting fraud, which is what many organizations have been doing for years, but big data really allows for a more sophisticated approach. So starting really from simple to complex, there are a number of ways to detect fraud. The first one is rule-based detection. The second is anomaly detection. The third is predictive analytics. And the fourth is social network analysis. So why is big data part of the solution? The main reason is that more data enables more analysis both in real time and over time. If you're thinking, I thought big data was too slow for doing something like this, you're somewhat correct. alone, Hadoop is a bit slow for something real-time, but with projects like Stinger and a hybrid in-memory approaches, this is actually becoming and is really a reality today. Which brings me to the final comment on this page. Financial institutions must approach fraud in a hybrid approach. We must start really looking at enhancing the data types that we're ingesting to detect fraud. And when I say data types, I know AJ is actually going to cover a wide variety of data types that are being deployed, or I should say being used now with big data technology. So I won't steal all that thunder. But so let's break this 4 types of fraud detection and look at how big data can help. All right, so the first level is fighting fraud using rules and known patterns. This is what we'll call rule-based fraud. It's the simplest to understand and frankly, to implement. And every bank has some form of this in place. Simple rules. For example, a rule states that you can't simultaneously take out $500 from 4 different locations, especially if there's no way that you could be in all 4 locations at the same time. But the problem is a bit more tricky. What if I took a flight from Charlotte to Atlanta, 45 minutes on a flight, one airport to another, and then I took out money on both those locations? What if I then flew 2 hours more and I took some money out in Dallas, Texas? And then what if I went to China and took out some money? Am I doing something wrong? Is there fraud? Or am I simply a world traveler taking the longest possible route to Hong Kong? Many of you probably have had your card turned off for reasons that the detection method isn't as sophisticated as it needs to be. All right, the next item is something that we're all very familiar with. Why are we familiar? Well, just like I said, because it's not working well enough yet. Hence the fact that we get our cards rejected. So if we look at this basic example, we have a number of transactions. The first 2 are normal, and the third is out of the ordinary. What we're looking for, or the anomaly portion here, is looking for data that does not conform to the expected patterns and is therefore declared an outlier. So big data comes into play here in that we can ingest a lot more data to really identify what is the normal. So a quick discussion of how this works. Hadoop can be used to build a much more rich version of, quote, normal. Your normal is then stored in an in-memory type of solution that active transactions can be bounced against. And we're actually going to look at a quick architecture diagram in a slide or 2 around this. Non-normal means that you're shut down in your credit card and a series of events that usually involves the phone call that you get. But this leads us to our third example, and yet more sophisticated. So you're probably wondering, how is he going to tie this into this discussion? The next level is predictive analytics. When someone goes from mundane purchases to high-priced dinners and gifts, are they in love or is the card stolen? Using anomaly techniques, we've been able to detect the outlier, but how do we know whether it's fraudulent transactions or emerging buying patterns? And hence the fact of predictive analytics, the term of data science. Big data and data science are so interlinked, and the reason is that data science is frankly a great place to be employed right now, is because the technology with big data allows for so much richer of exploration. So I could spend and have actually, we've got a webinar all on predictive analytics, but I'll keep this fairly short. The 3 methods here: predictive models analyze past performance to assess how likely a customer is to exhibit a special behavior in the future. Descriptive models quantify relationships in data in a way that is often used to classify customers or prospects into groups. In other words, am I a high roller, or am I, at best at Walmart? Decision models describe the relationship between all of the elements of a decision, the known data, including results of predictive models. and this is used then to forecast results for the decisions. Bottom line, this is a lot of data if you're going to really do this right, and a lot of complex algorithms. Organizations have been doing forms of this, but they're doing much, much more forms of this. There's a number of case studies that we could certainly talk about within this. All right, so the last and probably the most sophisticated, and you may say totally out there, is around social network analysis. But in case you're thinking that this is too futuristic, I actually stole this graphic from something that was done in 2002. So what if I played this forward? What if I, or let's say the financial institution, could store everything possible about you, your known business relationships, your friends, etc.? How does this have to do with fraud? What if I picked up on the fact that you were just indicted in a fraud crime? I then blacklist you, but I also go further and I build a list of your known acquaintances and put them all on a list of highly monitored individuals. In other words, I now expect them to try something. So anything even closer, or I should say close to out of the ordinary, is shut down immediately. Far-fetched? Well, with all the NSA discussions in the news, I think you all know that this is really not that far-fetched. But think of the potential for fighting fraud with combining all of these different technologies into a hybrid approach. So I'll end my portion of this presentation with this architecture or suggested architecture, and this is just an example of how you would put all of these different pieces together to fight fraud. This is, again, a sample of what a big data architecture would look like to support those four fraud detection methods. As you can see, moving from left to right, we're ingesting a wide variety, a large volume, and a high velocity. And if you've been around the marketing of big data, you know that I just mentioned the 3 V's, hence the fact that this is probably a great case for big data. We have a wide and several different methods of data ingestion. On the far right, we have a variety of tools to put this data into use, ranging from investigation to more simple visual analytics. And you'll also notice, if you look at the middle of the screen, we have a number of data hubs. And the data hubs are really used for real-time engines to validate transactions. So if you look at the full picture of this, it's a combination of storing a lot of data. It also has portions of analysis. It also has portions of real-time ingesting data and detecting types of fraud. All right, I'm going to turn this over to AJ, who's going to take us through a number of other use cases within the financial services. AJ?
Yep, thank you, Chris. And hello all, I'm Ajay. I'm Director of Technical Channels at Hortonworks. And in my capacity, I work with Pactera and other partners to bring big data solutions out in the market. Kurt, can we go to the next slide? So at Hortonworks, we work on a variety of big data projects across many verticals. And as we look back and analyze what people are doing across those projects, we can kind of boil it down to the fact that most people are using Hadoop as a platform to store and analyze new forms of data types. So whether that is sentiment, which is expressed in a forum on your website or on a social media site, whether it is people trying to analyze buying behaviors by looking at the activities that people have performed on your website, or it is trying to understand the failure patterns and predict failures based on instrumentation that is there inside of your equipment, whether that's a car, whether that's a manufacturing equipment, or whether that is your storage device. Every asset has been instrumented, and they are sending constant stream of information about their health, and to be able to capture that information in a cost-effective manner so you can do predictive analytics is a big use case for Hadoop and big data. The other data types where we see people leveraging big data technology, i.e. Hadoop, is around geographic data sets, so geospatial information, server logs to really analyze what IP traffic you get in your network. Is there a concern in the network traffic that is happening within your network, and also to analyze unstructured data, whether that is PDF documents or even audio and video files. So really, when we look at what people do with Hadoop, it is really to be able to cost effectively store, manage, and analyze these different types of new data that is being generated as a result of instrumentation that has happened across the board in the world that we live now. Okay, next slide. So when we take those data types and we look at how are those new data types being used in the financial services vertical and what use cases they are driving, here are some of the use cases, the business use cases that people are solving using the new data type. So there are a fair number of projects where people are using the new data type to do insurance underwriting, and I will go into further details about this use case. They are also using the new data type and the platform to get a better holistic view of their customer. They're using the click patterns to optimize their website. They're also using what people say on Twitter and Facebook to understand their affinity with a particular brand, and further using the new data types to screen account risks and accelerate loan processing. So let me dive into a couple of these use cases at the next level of detail in the subsequent slides. Good. So insurance underwriting, this is actually a project where we are personally involved in right now. And really in this particular instance, we are working with an insurance agency that is trying to bring to market personalized car insurance. So what is personalized car insurance? Traditionally, when we look at the car insurance market, we have been priced, the insurance has been priced based on fairly generic profile of an individual, and some of the criteria that have been accounted for are your age, your gender, the kind of car you drive, the color of the car you drive, what is your education level. But really what has happened in the past is an individual is categorized into these core buckets and given an insurance code depending upon the bucket that he falls into. A growing trend in the insurance market is to not simply categorize an individual into a course bucket, but to actually provide the insurance code based on individuals' driving pattern. So we have now leading insurers in the United States and really also in Europe, where they are offering opt-in programs for people to deploy telematic devices in their car, so the insurance agency can monitor their driving patterns, i.e. what time of the day do they drive, what speeds do they drive in, how often do they end up making sudden breaks, and by accounting for all of that information, they are now able to provide insurance codes that are much more specific to a particular individual and does not simply rely on course bucketing of an individual into a few dimensions that have traditionally been used. Now, this is not a future work. This is not something that people plan to do. That there is already plans in the marketplace right now that offers us as consumers the ability to price our own insurance based on our driving patterns. And the initial results on this is that for good drivers, the insurance premiums can go down by 30 to 40% over what would have been the case if you had not opted into being monitored and if you had not opted to be given a personalized code. The market today is said to be about 2% of the total car insurance market in the United States, and it's projected to grow to 10 to 15% of the overall market in the next couple of years. So if we look back at what is needed to enable this solution, is really a platform where you can aggregate lots of readings, and readings relate to the timing of the day, the speed of the car, the motion of the car, and you need a platform that first can hold a lot of this information, but can also hold it in an economical way, so that you are not spending you're not making lots of investment in your storage arrays and in your databases and data warehouses. And Hadoop really fits in very well to be able to host all of this information that is coming from telematics devices across all your customers or customers who have opted in, and then allowing banks and insurers to create personal profiles and personal codes based on individuals' driving patterns. So really a great use case for Hadoop, and a growing trend of what we expect to see in the market around personalized insurance. Good, next one. So the other use case that we are currently involved in involves website optimization, and really the bottom line over here that banks and insurance companies are trying to address is to improve the experience of the customer. Now, and at the same time to reduce the cost of serving the customer. We all know that every major organization has a web presence, and they have a lot of self-help abilities that they offer through their websites. Now, when we look at a consumer, typically a consumer goes to the website to look for information that he's interested in. If he does not find the relevant information or the relevant answer, the consumer may end up calling your call center, where he's first directed to the IVR system. He has an interaction with the IVR system, and eventually, if that doesn't help him, he ends up actually with a call center agent that records, that talks to the consumer and takes notes and memos in his call center application. So really, the interaction of the user, of the consumer in this particular instance, is spread across the website. It's captured in your IVR system, and is captured within your call center application. To truly be able to understand what optimizations are needed on your website, to truly be able to understand what questions lead the consumer to actually making a call and to be actually talking to a call agent, you need an ability to combine all of these interactions into a common platform. So keeping your website information siloed from the information that is captured by your IVR system to the information that is held within your call center application, if you keep them all siloed, you do not get a holistic view of really what the root cause of the problem is that's leading the consumer to call the call center and the call centers that you have set up. And Hadoop, again, offers an excellent platform for people to aggregate information across the website, the IVR system, and the call center applications so they can get a holistic insight into what improvements can be made to both serve the customers more effectively and to reduce the cost of operations while serving the customer. So this is again a very common use case, trying to analyze interactions in a holistic manner across all the different channels that you have and using Hadoop to enable this analysis. Good. Right, and the last in the proverbial use case for Hadoop is the 360-degree view of the customer. This isn't necessarily a new problem. This problem has always been in existence and seems like an endless chase where we have tried to get a better understanding of who my customer is, what products have they bought, what are the new products that I can take to the customer and propose to the customer. So this isn't necessarily a new problem, but Hadoop is bringing the technology capabilities to allow you to finally tackle this use case. So again, what typically happens in a big financial institute is there are multiple channels by which a customer interacts, and there are multiple products and portfolio of services that the consumer ends up, and or the customer ends up buying from the bank. Many a times there is no single holistic view of what the consumer has bought, and neither is there an ability to analyze what is the new product that should be proposed to the consumer. So if we take a look back at what is happening in the retail vertical, a company like Amazon is making 30 to 40% incremental revenue, incremental sales by simply being able to analyze what is it that the customer has bought and then mapping his interest, mapping his profile to other consumers so they are able to propose and recommend new offerings and new products to the customer. At Amazon, a study from a couple of years back has uncovered that 30 to 40% of revenue that Amazon generates is purely based on the recommendations that they make to their customers. And what we are now starting to see in the financial services industry, in the banking and the insurance industry, is the same desire to be able to first get a comprehensive view of the customer, so you understand what are the products and services that he is already subscribed to, and then to be able to profile the customers and find other products that you can recommend as future services for the customer. So really taking the learnings of the retail industry and the value that they have seen by being able to profile and recommend new offerings. We are seeing that being adopted in the financial services vertical as well. And again, Hortonworks is involved in a number of these projects in conjunction with our systems integration partners such as Pactera. Okay, on to the next slide.
All right. Well, thank you, AJ. So we're going to end the presentation with just a couple additional slides that, talking around next steps. So Chris mentioned early on in the presentation around where you could go to get more information, and he also called out specifically the Hortonworks sandbox. I'd highly, highly recommend that. It's a great place to start if you're just wanting to begin to explore from a technical perspective. The sandbox is a great thing to download and begin playing. So definitely hit that. It's obviously on the Hortonworks website, hortonworks.com. Hortonworks also offers a number of great classes. I can attest to that because I've been to several of them. So definitely take them up on that. From a Pactera perspective, this slide is really kind of demonstrating how we help companies. To put it shortly, we help companies from architecture through deployment and maintenance. We've got a number of resources that can help, as well as I should also call out the data science role that we're seeing that is so tightly glued with big data projects. So how do we tactically help? How do we get involved with companies? There are some things that we do, frankly, for a sales and marketing perspective, and that's around these workshops that we will gladly engage with companies at no cost to basically help you understand what you could do with big data. So we call those really workshops. And then normally companies go straight into pilot projects that are the result of the workshop. So within the workshop, there's a bit of education, there's a bit of brainstorming about how or what you could do next. All right, I'll take a couple questions. We're running pretty tight on time. The first question that came in was, what type of technologies existed before Hadoop? That, and I'm assuming the question, I'm gonna assume a few things here, so hopefully I'm not totally wrong. The question is around some of the fraud. So the question would be, what type of technology existed before Hadoop that helped fight fraud? And I think the one slide that we discussed that was around a polyglot approach is probably the slide to reference, and that is that, people have been, especially financial institutions, have been determining methods to fight fraud and used whatever technologies that existed. So tools like SAS and R from predictive analytics and traditional database vendors from whether it's Microsoft or Oracle or IBM. And then middleware technologies for some of the quicker event-driven things like TIBCO or MQ series type of products. So, and I think what we tried to demonstrate in the polyglot slide was really that you're going to continue to use a lot of those technologies. Big data does not replace everything. It makes it better. It may replace certain aspects, but it certainly allows you to store more and do things faster and in a more efficient manner. All right, the next question, what is the difference between Hortonworks and the competition? AJ, you want to take that one?
Sure, Kurt. So there are a few differences between, there are a few choices for Hadoop in the marketplace right now. And we definitely, a lot of our customers look into different offerings of Hadoop, and many of them end up selecting Hortonworks data platform as their choice of Hadoop. And a few critical reasons for why people choose to work with Hortonworks is, first and foremost, they understand that what they call Hadoop is really work that the engineering team at Hortonworks has done. So if we look back at the code contribution that the engineering team at Hortonworks and the engineers at Yahoo, who has a minority stake in Hortonworks, has done and contributed to the open source Hadoop project, our percentage of contribution is in excess of 70% between Yahoo and Hortonworks combined. So when companies look at their Hadoop platform and which Hadoop vendor they want to work with, they tend to favor and prefer to work with Hortonworks because they realize that we are the team that has written the code, and as a result, we are the team that would be best positioned to support them. The second reason for why people choose to work with Hortonworks is because we have 100% open source business model, i.e., we do not include any offering in our distribution of Hadoop that is closed source or that is not done as an Apache project. And the advantage of working with a vendor that is 100% open source is that you do not end up spending money without first realizing the value of the platform. And also it makes it really easy for you to shift and change your strategies around Hadoop and go to an alternative vendor. This freedom of choice for our customers also makes sure that we are always at the tip of our toes and serving our customers in the best possible manner. And the third reason, so we are leading and shepherding Hadoop development in the open source. We have an extremely responsive support organization, and we do everything that is 100% open source, so there is no licensing cost to any of our offerings. And third reason for why people choose to work with Hortonworks is really the ecosystem. So we work and partner with people that you trust and work with. Microsoft, Teradata, SAP, Rackspace, HP, all of the biggest IT vendors that you trust and you work with recommend and partner with Hortonworks. So those are really the three key reasons for why people choose our platform.
All right, thanks, AJ. Well said. I'll take one more question here, and then we probably need to close it out. There were a few other questions, but we'll answer those offline. The question is, what do most financial companies do first in this space? Well, obviously, the answer is, I'll take this one, but the answer is probably some level of my opinion. But I think the answer is actually probably in an earlier slide that AJ presented, and what we see, because we do business with a lot of the larger financial institutions, is that cost is right up there just for the sheer size and maintenance of storing the data. But typically, if business funding is involved, it's found in something that's achieving some new business objective, whether that's the elusive 360-degree view of the customer or some of the other things that we chatted about. And it's usually stored, and this is usually how we drive the questions. It's usually stored in one of the new data types, like AJ mentioned, around sentiment, clickstream, sensor, geographic, server logs, text, data types that weren't able to be consumed before. So if you're considering doing something, you may want to just start as simple as asking, are there these data types that we've previously done nothing with, but could really add a lot of value to some of our current processes. Well, I want to thank AJ and Chris for being on here and for taking the time to present today with myself. And I also want to especially thank everyone who did attend today. If you have any additional questions, our email addresses are up on the slide there, and we look forward to chatting with you later. Thank you.